Far out in the dark, something immense is slowly turning. It has been turning for something like 13 billion years, and it will go on turning long after this quiet hour has been forgotten. A great wheel of light and shadow that we happen to live inside. There is no need to do anything with it tonight. Let the breath lengthen. Let the shoulders give. Let the weight of the day loosen its grip, as though the pull of the floor beneath you had gone soft. We are not going to point at constellations or name the brightest stars. We are going to drift slowly. If a slow wander like this is the kind of thing that loosens your thoughts at the end of a day, a quiet nod to the channel, a like, a word left below, helps another tired mind find their way to a night like this one. None of it is urgent. There is nothing here to chase, only the long turning and 100 small wonders to let go of one by one. Begin with where we actually sit, because it is humbler than most people imagine. The sun and its planets do not ride in one of the galaxy's grand, sweeping lanes of stars. They drift instead through a modest side channel, a short bridge of stars, sometimes called the Orion Spur, tucked between two of the larger arms. It is not crowded here, and it is not especially busy, and that ordinariness may be exactly the point. Out in the dense, blazing lanes, exploding stars and floods of radiation come far more often. In this calm little gap between the highways, the violence is rarer, and the quiet runs longer. Perhaps just long enough for something as fragile and slow as life to take hold and keep going. Quiet as it feels, nothing here is standing still. The whole solar system is racing around the galactic center at well over 800,000 kilometers in an hour, better than 200 kilometers in every single second, and yet the loop is so unthinkably wide that a single trip around takes roughly 250 million years to finish. Astronomers call one of those laps a galactic year. Measured that way, the sun is young. In all its 4.5 billion years, it has carried its planets around the center only about 20 times. The last time this corner of the sky looked the way it does now, the great single landmass of the ancient Earth was only beginning to crack apart, and the first dinosaurs had not yet drawn breath. The path is not even a tidy ring. As the sun sweeps along, it also rises and sinks through the flat plane of the disk, bobbing up and then drifting back down across spans of tens of millions of years. The way a float lifts and settles on a slow swell. The galaxy's own mass tugs it back each time it strays too far. Some researchers have wondered, cautiously, whether that gentle vertical rhythm might line up with the long cycles of dying out and renewal in Earth's fossil record. The evidence is far from settled, but it is a soft thing to hold in mind, that even on its steady road around the center, our star is not gliding flat. It is swaying almost imperceptibly through the dark, and here is part of why the whole shape is so hard to picture. We are stuck inside it. There is no way to climb above the Milky Way and look down on its spiral, the way the diagrams show. We only ever see it from within. Edge on. then field of arise a clear night, bent and on then but it is rather like standing deep in a forest and trying to map the wood by squinting along the rows of trunks. It took centuries of patient watching, counting, and careful reasoning before anyone worked out that the faint river overhead was the disk of a spiral, seen from the inside. We belong to a shape we have never once stood back far enough to see, so it should be no surprise that even simple-sounding questions stay open. Ask how many spiral arms the galaxy has, and the honest answer is that nobody is certain. For a long stretch, it was taught that there were 4 main ones. Closer looks have muddied that. Maybe there are fewer grand arms than that, with the rest fraying into spurs and branches, some fading to broken fragments, some curling around in ways no neat pinwheel would allow. The galaxy may be less a clean diagram and more a living, layered swirl shaped by forces we still only half understand. Most of that swirl, in any case, is completely beyond our sight. On a truly dark night, far from any town, a sharp-eyed person might pick out a few thousand stars, which feels like a flood until you set it against the whole. The Milky Way holds well over 100 billion of them. The overwhelming majority are simply unreachable to the eye, shrouded behind thick curtains of dust, or too faint or too far. That soft glowing streak across a moonless sky is only the nearest hush of the thing. We are afloat in an enormous river of starlight, and almost every drop of it never reaches the eye at all, too immense to hold from where we happen to sit. The stars in that river do not even keep to one orderly pace, unlike planets which trace tidy rings around their sun. Stars in the galaxy move with a looser freedom, some hurrying through the inner regions, others drifting slowly along the rim. That spread of speeds is part of why the spiral arms appear at all. The arms are not solid rails of stars. They are patterns, slow pile-ups, a little like a knot of traffic that lingers on a motorway while individual cars roll in and out of it. Where these crowding waves move through, gas is squeezed and fresh stars catch fire, edging the lanes with ribbons of young blue-white light. Our star itself keeps sliding in and out of those patterns across the ages. The galaxy is less a clock than a current, and we are simply adrift in it. That sets the stage. A quiet seat in a calm spur, a long swaying lap measured in hundreds of millions of Earth years, a shape too large to step outside of, and a current of more stars than the eye will ever count. From here, we can begin to move inward, outward, and back through time, slowly, with nothing to reach for, into the deeper and stranger truths of the wheel we live inside. Look closely at that disk, and it turns out not to be one flat sheet at all, but 2 layered together. The part we sit in is the thin disk, a broad, bright plane crowded with younger stars, loose clusters, and the gas that is still busy making more. Wrapped above and below it lies a second, older layer. The thick disk, puffier, dimmer, and noticeably poorer in heavy elements. Those older residents tend to ride on tilted, stretched-out paths, as if they were stirred up long ago, or laid down under rougher conditions than the calm plane that came later. The disk is less a single floor than a thing with sediment in it, settled in bands across enormous reaches of time. Follow the disk inward, and the middle is stranger still. The core is no smooth, rounded ball of suns. It is a long, thick stripe of them, a bar, a glowing bridge laid across the center, slowly rotating and dragging the inner spiral lanes along with it. Bars like this are ordinary among spirals. They grow as disk stars start crowding inward and gathering along one axis, and over time, the bar firms into a lasting engine, churning gas and funneling fresh material down toward the very center. And inside that bar, there are hints of yet another, smaller bar nested within it, tipped at its own angle and turning to its own beat, hard to make out directly through all the dust and distance, but betrayed by the way the nearby stars and gas seem to move. The heart of the galaxy is not one clean shape, it is a layered tip that bulge on its side, and it shows a shape no one expected. Not a sphere, but something closer to a peanut, swelling in the middle and pinching at the ends, almost like an hourglass molded out of stars. Knob Glau molded out of steered his countless herbulate its slow We picture a spiral as something flat and tidy. Its center is anything but intricate, three-dimensional, quietly alive. Step back to take in the whole platter, and even the flatness is a polite fiction. The disk is warped. One side lifts gently upward and the far side dips down, so the galaxy carries a long, slow wave across its outer reaches. The bend stayed hidden from us until radio telescopes traced the cold hydrogen that drifts out well past the visible stars. The likeliest culprits are the smaller galaxies tugging at the rim, or knots of unseen mass pulling the disk out of true from below. And the warp itself turns a vast ripple wheeling slowly through the stars, like a spun plate nudged a little off balance. From close up, we feel none of it. From far enough away, the galaxy is no crisp pinwheel but a breathing, undulating sheet curving softly as it spins. That lopsidedness runs deeper than the warp. For all the neat, even diagrams, the galaxy is subtly off balance in several directions at once. One flank of the disk thicker than the other, some arms brighter or longer or more sharply curved than their partners. The faint outer halo sitting slightly off-center. Even the star counts not quite matching from one side to the next. Such imbalances are most likely the bruises of old encounters, gravitational brushes with the satellite galaxies, the pull of unseen dark matter. The scars of mergers long past. Like a living thing, the galaxy carries its history in its shape, wrinkles of time, a graceful imperfection worn into it by everything it has. Beyond the bright platter entirely lies a realm much more diffuse, a vast, near-spherical halo that wraps around the whole galaxy. It is sprinkled with the oldest stars, with tightly bound clusters, and with enormous quantities of dark matter, and though it gives off almost no light, it may hold the greater share of everything the Milky Way weighs. Its stars are scattered thin across staggering distances, swinging on long, unhurried arcs that hardly ever brush the disk. The halo also keeps the leftovers of ancient swallowings, faint streams and shells of stars peeled from smaller galaxies and abandoned out there, like fossils in the cold. It is the galaxy's outermost memory, dim, patient, still slowly turning, still shaping what the whole becomes. Riding in that halo are some of the oldest things the galaxy owns, more than 150 globular clusters, dense knots of hundreds of thousands of stars packed into tight glowing spheres. They loop around the center like moths circling a far-off lamp, remarkably steady, several of them older than 12 billion years, and many holding stars that were already shining before the Milky Way had finished assembling itself. Their stars are starved of metals, born before the cosmos had time to forge much of anything heavier than the lightest elements, which makes each cluster a kind of sealed capsule, a record of how the galaxy came together, what it once devoured, and what the young cosmos was like. They drift on, gold and quiet, above and below the plane, glowing softly against the dark. None of this great structure turns all of a piece. The inner regions wheel around far faster than the outskirts. Near the core, the gravity is fierce, packed with the weight of stars, gas in the central black hole. And stars there whip through tight, swift loops, closing a circuit in mere millions of years. Further out, in the galactic suburbs where our sun lives, the pace slackens to hundreds of millions of years per lap. That mismatch is what twists the arms into their long curves and stops the disk from turning like one solid plate. The wheel turns, but its rim forever lags behind its hub. And the arms themselves, so apparently permanent, are not fixed trails of particular stars at all. They are patterns, waves of denser material rolling through the disk, squeezing the gas they pass and kindling new suns that flare for a while and then slide out the far side as fresh ones ignite behind. The shape moves at its own rate, separate from the stars that swim through it, which is why it holds together as form, even though nothing in it stays put. There is even a special distance from the center, the co-rotation circle, where the stars and the wave happen to keep step, neither overtaking the other. Our sun rides close to that quiet boundary, and that may be another small mercy, sparing us frequent plunges through the crowded, dangerous arms, leaving us in a steadier neighborhood, sheltered not by any wall, but by the simple grace of matched motion. Here is where the gentle facts turn quietly unsettling. By every reasonable sum we can do, the galaxy ought to be tearing itself to pieces. Weigh up everything that shines. The dust. The dust. And there is nowhere near enough of it to we it's frank-rangen in and out of the fangwini outer, yet they stay. Something we cannot see is holding them, and there is a great deal of it. That something has a name, even if it has no face. Dark matter. It gives off no glow, throws back no light, swallows none. It simply pulls, and it pulls so heavily that its weight runs to several times that of every visible thing in the galaxy combined. The clue first showed itself in the way the wheel spins. Old, careful physics says the farther out you go, the slower an orbit should be. Exactly as the distant planets crawl while the near ones hurry. The galaxy refuses. Stars far out near the edge swing around almost as briskly as those deep inside, which simply should not happen if the only mass present is the mass we can find. Fold in an unseen halo of extra weight. The wheel turns evenly, not because we have understood it, but because some hidden thing is steadying it from out of sight. The deeper shock is just how lopsided the accounting is. Nearly all of the stars we can actually see lie inside the flat, bright disk, and yet most of what the galaxy weighs is somewhere else entirely. It sits in that enormous dark halo, reaching far past the last visible star, outweighing the luminous disk by a wide margin. The halo is sprinkled only thinly with ancient stars and clusters. Its real bulk is unseen. When we picture the Milky Way, we summon the spiral lanes and the starry plain. But that is only the glowing skin of it. The true mass that sets how it pulls, how it moves, how far it reaches, lies mostly out of sight, folded around everything like a quiet shroud. And we still cannot say what the stuff actually is. It pours straight through ordinary matter as though that matter were not there. It neither shines nor casts a shadow. We know it only by its pull, by the way it bends the paths of the things we can see, by the speed of stars that have no business moving that fast, by the way the largest structures in the cosmos came to be arranged. Strip it away, and the galaxy would simply scatter. It is the scaffolding nothing rests on, and everything depends upon. Invisible, silent, and still among the largest open questions in all of science. You might assume that, of all things, we would at least know how heavy our own galaxy is. We do not precisely. The shining matter is only a sliver of the whole. The rest hides in that dark halo we cannot weigh directly. Estimates scatter. Some settle near 1 trillion solar masses. Others climb considerably past that. And the spread comes from the sheer difficulty of clocking how fast the most distant stars are traveling. A measurement blurred by thin data and by all that unseen weight pressing on the result. The Milky Way is the place we live, and its true heft remains a soft, standing mystery. For a long time, the assumption ran the other way about its great neighbor. Andromeda looks a touch larger and brighter, so it was taken to be the heavier of the two. More recent work has begun to unsettle that. If our own dark halo is broader and denser than people once granted, then our galaxy might just be the weightier one after all, for all its more modest glow. When the two spirals finally come together, far in the future, the balance of their masses will steer how the whole encounter unfolds. The Milky Way can seem the gentler of the pair, and may, beneath its quiet arms, be carrying more than anyone long supposed. What the eye takes for a calm band of stars is, in truth, roaring across registers we were simply never built to sense. The galaxy is awash in energies far outside the thin slice of light our eyes can catch. Streams of fast particles race between the stars. Faint glows of X-rays and harder radiations seep from dying suns and from the rims of black holes. Long, low radio notes drift out of cold gas and spinning remnants. When a person looks up on a clear night, they are reading only a single narrow line of the galaxy's full score. Underneath it, the wheel is humming in countless other colors and frequencies at once, a hidden music playing in the dark. Some of that hidden energy hangs in shapes almost too large to credit, reaching upward of some 30,000 light-years from the center, and as far again beneath it, float two enormous, faint lobes of high-energy light, swelling out of the galactic heart like a pair of vast, ghostly balloons. They were only noticed fairly recently, and no one is wholly sure how they came to be. They may be the cooling aftermath of some long-ago eruption from the central black hole, or the bruise left by a fierce burst of star-making that once raged at the center. However they formed, these silent towers loom over the disk, unseen by any eye. A reminder that the galaxy has a past we cannot quite read. Thou how and how trich how the how turn an X-ray telescope on that same quiet spiral and a fiercer portrait appears. The core pours out hard light, so do collapsed stars and the searing rims around black holes. Burnt-out white dwarfs and dense stellar corpses, locked in pairs with ordinary companions, can pull matter off their partners and heat it to millions of degrees until it screams in X-rays. Even the thin gas in the outer halo gives off a faint, high-energy shimmer, sketching the galaxy's broader skeleton. None of this reaches us as visible light, but instruments tuned to those wavelengths paint a wholly different Milky Way. Not a tranquil pinwheel, but a place of extreme heat, crushed remnants, and radiation we would never guess was there. Where dust and distance block ordinary light, longer waves slip straight through. Radio carries past the curtains that hide so much of the galaxy from sight, tracing the cold hydrogen, outlining the magnetic threads, picking out the pulse of spinning remnants and the wreckage of old explosions. With rings of linked dishes, astronomers have followed the spiral lanes, gauged the bend in the disk, and turned up nurseries of new stars wrapped in darkness. Where light is shut out, radio lets us listen our way to the shape underneath. The galaxy speaks in a tongue no ear can hear, one that patient science has learned, slowly, to translate into form and shadow. Among the steadiest of those radio voices are the corpses of massive stars. When a great star dies and falls in on itself, what is left can be a tiny, dense ball spinning at a furious rate, throwing out narrow beams of radiation that rake across space. Some turn hundreds of times a second, and each sweep of the beam arrives in a rhythm so regular it can be timed like the tick of a flawless metronome. That precision makes them useful by tracking their beats. Astronomers measure distances, put gravity to the test, and even hunt for the faint stretching of space itself. All across the galaxy they blink quietly away, the relics of stellar death and yet beacons of astonishing order, keeping time not over hours or days, but across whole ages, tapping out their steady count in the hush between the stars. Other messengers from those same violent places slip through us without the faintest knock. Each second, a flood of high-speed particles, flung outward long ago by exploded stars, pours through the body and onward, bending along magnetic lines, glancing off clouds, now and then striking an atom high in the air, and bursting into a brief shower of lesser particles. We almost never feel them, yet they carry word from across the galaxy, traces of ancient blasts, hints of distant places where matter is hurled to staggering speeds, dispatches from the savage hearts of stars. Even at rest, even half asleep, a person is quietly rinsed by this rain out of the dark. Stranger still are the ghost particles. By the countless trillions they stream through everything, the planet, the walls, the sleeping body, born in the nuclear fires of the sun, in collapsing giants, in the collisions of fast particles with atoms out in space. They weigh almost nothing and react with almost nothing, so they pass clean through solid matter as if it were open air, leaving no mark at all. To catch even a handful, scientists bury great tanks deep underground or beneath polar ice and wait for the rare flash of a single collision. What those particles carry is news from places no telescope can reach: the cores of stars, the throats of dying giants, the unseen furnaces of the galaxy. And the galaxy is touched, too, by trembles in space itself. All across the universe, heavy things crash together. Black holes wind inward and merge, dead stars smash, whole galaxies fold into one, and each such event sends out a faint shiver through the very fabric of space and time. A few of those shivers wash through the Milky Way, stretching and squeezing distance by amounts almost too small to imagine. They are brutally hard to catch, yet sensitive detectors on Earth have already felt several pass, and newer efforts aim to hear the low background hum of all of them together. Even now, while the world sleeps, space is flexing by the faintest whisper. Far too little to sense, and still enough to say that somewhere, unimaginably far off, the universe has just rearranged itself. At the very middle of all this slow turning sits something with no mercy in it at all. A single point of crushing gravity anchors the galaxy. A supermassive black hole, carrying the weight of more than 4 million suns, yet folded into a region no wider than the little orbit of the innermost planet. No telescope sees it directly. What gives it away are the stars nearest in, which tear around that empty-looking spot at blistering speeds, scribing tight, invisible loops in the void. Every so often, a shred of gas or dust spirals down toward it and flares with hard radiation on its way over the edge. For now, the thing lies quiet, but it is the still hub. The whole great wheel leans on, drawing the inner stars into a slow, relentless dance they cannot leave. Quiet now does not mean quiet always. There are signs that this same dark center once blazed, the vast lobes of high-energy light above and below the core, and faint echoes of fierce radiation caught in distant clouds hint that long ago the central black hole may have flared into something far brighter. The kind of brilliant, savage beacon that pours out when matter floods inward all at once. Such cores can outshine an entire galaxy from a single point. If our own heart once burned that way, the Milky Way would have looked utterly unlike the calm spiral overhead now. A quiet pinwheel wrapped around a blinding, ferocious center. That age is gone, but its fingerprints linger in the dark. That center does more than swallow. Sometimes it spits. Most stars wander the galaxy at gentle, ordinary speeds, but a rare handful get hurled outward fast enough to break free of the Milky Way altogether. Some are the leftovers of pairs of stars that strayed too near the central black hole. One partner is captured and dragged down, while the other is flung the opposite way, catapulted into the dark at well over 1,000,000 kilometers an hour. These runaways travel alone, far above the crowded plain, like comets that will never turn back. They are a reminder that even in a place bound together by gravity, there are sudden, brutal partings. Dude, Idings. Nearly every star is held fast by the galaxy's pull, but now and then one is pushed past the threshold, somewhere above 500 kilometers in a single second, and once across it, there is no coming home. A few are kicked loose by the central black hole. Others are slung free by chance three-way encounters between stars, or by a partner detonating beside them. From that moment, they are travelers in the truest sense, drifting out into the emptiness past the spiral's rim. Tiny lone lights carrying a piece of the galaxy's story away with them. Solitary pilgrims wandering the great dark between island worlds. Many of those partings begin with a bond being snapped. A great number of stars live not alone, but in pairs, two suns wheeling about each other in a long gravitational embrace. Even that tie can be undone. Let a pair pass too close to the central black hole, or thread through one of the dense star cities of the halo, and the tides can wrench their orbit apart, capturing or slowing one, while the other is thrown clear, sometimes flung straight out of the galaxy as a runaway. These breakups happen quietly, in places we almost never watch. An ancient companion torn in an indidus trap to cornet and dad frant and the cran to cran. Other upheavals are creative, even as they destroy. When a heavy star reaches the end of its life, it collapses and detonates. A blast so fierce, it can briefly rival the glow of a whole galaxy. But these explosions do not only end things, they begin them. And it sows the space around it with heavier elements, the iron that will one day run in blood, the precious metals locked away inside planets, forged in the furnace of the dying star and thrown wide. In this way, each death works on the galaxy like weather, stirring it, enriching it, reshaping whatever lies around it. These are the wheel's fits of fury, wrecking, radiant, and somehow necessary. And in the most crowded corners, stars do something space almost never allows. They touch. Space is enormous, and stars are tiny, so collisions ought to be impossible. Yet in the packed hearts of the densest clusters, suns can pass near enough to pull on one another, and, once in a long while, to merge. Should that happen, the outcome can be startling. A flare of light, two stars folded into one, or an odd blue star that looks far younger than every neighbor around it, born again from the union. Such mergers are rare, but not impossible. Across billions of years, even the tightest stellar neighborhoods slowly rearrange by gravity and sheer chance. In those crowded cities of suns, time runs to a different measure, and the space between stars is never quite as empty as it seems. For all that ending, the galaxy is just as busy beginning. Drifting all through it are huge dark banks of cold gas, the raw stock from which suns are made. These clouds are mostly hydrogen, with a faint dusting of grains, and some sprawl across hundreds of white years. Deep inside their cold, dense folds, gravity quietly begins to gather the material into knots, and the knots tip over into becoming stars and worlds. A few of these clouds are so vast and so frigid that they soak up visible light altogether, standing as black gaps against the spangled sky. They are the wombs of the galaxy, silent, hidden places where the next chapter is already taking shape, tucked behind veils of shadow and gas. The making itself is a slow falling in. Within those frigid clouds, chilled to only a breath above the coldest temperature there is, gravity takes hold a little at a time. A small patch grows denser than its surroundings and begins to collapse under its own weight. As the gas tumbles inward, it warms, it spins, it flattens, and at the heart of the whirl, a young star gathers. A protostar, not yet truly lit. The pressure and heat keep climbing until at last, fusion catches deep in the core and a new sun draws its first light. Out of the very coldest shadows come the brightest things in the sky, spun gently into being by nothing more forceful than gravity and time. Gather enough of that fresh fire in one place, and it draws the spiral itself. The galaxy's arms are not merely lines of stars. They are stitched out of the birthplaces of stars. As those giant clouds of gas and dust sweep through an arm, they are squeezed and kindled into clusters of newborn suns. And the fierce light of the youngest, hottest of them set the surrounding. These regions blaze chaotic and bright, washed in radiant blues and silvers, and it is exactly this rash of new light that traces the curves of the arms across the disk. Every sun that has ever shone, our own included, was lifted long ago out of one of these glowing cradles of gas. Much of that creation, though, happens where we cannot watch. The galaxy is full of light the eye will never receive, because between the stars hangs a fog of fine grains, flecks of carbon, of silicate, of ice, drifting in clouds and tendrils. In ordinary light, this dust simply blots things out, hiding whole regions and entire glowing clouds behind it. But the birth goes on behind the veil. Instruments tuned to heat can see straight through the murk to the glittering nurseries packed with new suns inside. What looks like a patch of nothing is so often a nursery. The dust that conceals is also part of the work, soaking up energy, helping the gas cool, sheltering the most delicate stages of a star coming into being. What seems like emptiness is so often the start of something bright. Not every cloud takes the plunge. Scattered through the galaxy are great cold banks of gas that look ready to fall in on themselves, and simply do not. Some are spread too thin. Others may be propped up by magnetic fields threaded through them or kept churning by their own restless turbulence. These barren clouds float on like held breath, rich in the molecular hydrogen that makes stars yet never lit by any fusion. One day a few of them may ignite. Others may be torn to shreds by some passing force first. Their gas folded back into the general supply to try again elsewhere. In them, the galaxy pauses, waiting, perhaps, for the right small nudge to spark something new. Even the overall pace of making has eased. In more recent ages, the tempo has fallen off. There is still gas to be had, but a great deal of it lies too thinly scattered, or warmed, or locked into forms that resist gathering. The galaxy is not finished building stars. It is merely settling into a calmer stride. The high tide of star-making crested an age in the past, and has been ebbing slowly ever since. That is not the approach of any ending. It only means we live in a gentler chapter. A grown spiral glowing softly through its middle years. Still kindling suns, but no longer in any rush. And the suns it does make rarely arrive one at a time. Most stars are born in company, in clusters drawn from the same collapsing cloud, bound for a while by their shared gravity and drifting together for many millions of years. But in time, they scatter. The galaxy's own tides, near misses with passing stars, and the cluster's own inner restlessness all work to loosen the knot, and the stars drift off one at a time until the group melts into the ordinary background of the galaxy. Our own sun, too, was almost surely cradled in such a cluster long ago. Its thousands of birth siblings now wandered far, faded, or lost somewhere in the blur of distance. A family quietly scattered across a sea of light. Some of those newborns spin at speeds that beggar belief. Nearly every star turns, but a few wheel round so furiously they finish a full rotation in mere hours. These breakneck spinners are often young, massive, and unsteady, their middles bulging outward under the strain, sometimes flinging off rings of their own matter into glowing disks around them. Our own sun takes the better part of a month to roll over once. These others turn hundreds of times faster, pressing right up against the physical limits a star can bear. Their inner workings and their destinies differ from the steadier suns. They may not live long, yet while they burn, they whirl like dervishes against the dark. Around many of these stars, almost as an afterthought of their birth, worlds gather, Planets are not some rare cosmic luxury. They are the ordinary leftover of making a star. As a new sun ignites, a spinning disk of surplus gas and dust wraps around it, and within that disk grains stick, gather, and slowly swell into worlds. Right across the galaxy, planetary families are common. Some are grand, ruled by giant planets and frozen moons. Others are tight little systems of rocky worlds hugging close to a dim star. Some echo our own, and some defy anything we would have expected. The galaxy is not only a place of stars, it is a place of whole systems, small solar households, each with its own balance and its own quiet possibility. Even the gaps between the stars turn out to be doing something. That apparent emptiness is actually a faint, moving mixture. Sign, rated eye, rocker, crowd. Tune a radio dish or a heat camera to it, though, and it grows wonderfully busy, pulled into long threads, puffed into hollow pockets, rumpled by the pressure fronts of old blasts, and gathered into chill, dense knots where new suns get their start. Dying stars punch caverns through it. The winds off living stars sculpted into forms that stream away for light years. Far from being a blank, it is the cloth the galaxy is cut from, and the place where, sooner or later, life manages to begin. None of that mixture sits quietly. Up close it heaves and roils, kicked about by blast fronts, by magnetic strain, by the steady passage of the stars through it. Heat and chill alternate from one patch to the next. Rivers of material run together, blend and shatter. Whole banks of it fold and topple. Taken all together, it amounts to a slow churning. An ocean in no hurry, sloshing through the disk over ages. How stars are born, how the fast particles roam, even how the galaxy ages. All of it is bent by this unsettled sea. The serene starlight of a distant view is, near to hand, a restless and rippling thing. A force with no shine of its own runs through every part of that sea. Magnetism threads the whole galaxy, through the flat disk, up into the surrounding halo, all along the thin gas in between. Set against a compass on Earth that is laughably weak, yet stretched across such reaches it counts for a great deal. It nudges the paths of speeding particles, leans on collapsing clouds, and helps route the drift of matter through space. It tends to follow the line of the arms, bows up over the plane, and coils into loops that no tidy rule will explain. Mapping it asks for radio eyes and slow, careful study, but there is no missing it. The galaxy does more than glow. It carries a quiet electric pulse all through its frame. Those same magnetic lines even take the dust in hand. The little grains adrift between the stars are not steered by gravity by itself. They feel the field too. It runs through the galaxy like unseen wiring, marshalling charged motes and tipping how gas and dust fall into rank. In one place, a grain may spin hard and leak a faint microwave gleam. In another, it may settle along the field and lend a slight lean to the light passing by. Teasing those effects apart lets astronomers sketch the field's geometry, and even strip its fingerprints out of delicate readings of the oldest light there is. Dust does nothing idly. Up the magnetism, etching quiet figures into the dark. For all the stirring within, the wheel alskays bush from behind freedom. Fresh gas keeps arriving from the wide gulfs between galaxies, sliding in along faint trailing threads of the larger cosmic lattice. That incoming supply is the stock the galaxy will spend on suns not yet made, refilling what time keeps draining away. Some of it eases in cold and quiet, folding gently into the disk. Some falls in hot and shocked, flaring in ultraviolet or in X-rays. These unseen channels keep the place fed and forever shifting, lashing it to the broader universe. Tonight, as much as ever, the galaxy is taking long drinks from distant stores, fed by strands of matter left over from the dawn of things, and whatever flows in must, now and then, be let out. Where heavy stars cluster and die together, their massed explosions gouge huge voids in the gas, and the voids can run together into single vast hot pockets that blow straight up through the disk and empty into the halo. What forms is something like a flue, a vent through which heat, gas, and magnetism leave the flat plane behind. These vents help govern the pressure of the gas, sow heavier elements through the surroundings, and shape the halo overhead. By this trick, the galaxy takes a kind of breath, not only across its disk, but up through tall stacks that send its energy climbing into the dark. Stretch that breathing over ages, and it becomes a slow loop. Over the disk and under it, material lifts and sinks in a long circuit. Heat from dying stars and the push of stellar winds drives gas upward into the halo. Out there it cools, draws together, and rains softly back to the disk across millions of years. Around it goes, stirring the gas, spreading the heavy elements wider, keeping the rate of new stars in check. It is a hushed sort of breathing, a long drawing in and letting out of matter between the crowded plane and the open halo. Turning is only half of what the galaxy does. The rest is this patient circulation, an inhale and an exhale measured against time too vast to feel. Some of those old outbursts leave scars that linger for an age. Here and there, the galaxy wears enormous rounded shells of gas, a few of them hundreds of light years wide. They are what remains when a knot of heavy stars forms together, burns through its short, fierce lives, and goes off in a rapid string of blasts. The combined winds and detonations scooped great hollows in the gas and shoved it outward on every side. The swelling slows as the ages pass, but the shells hang on, pale bubbles marking ground where the wheel once blazed with the making and the dying of stars. The embers of a fireworks long finished, still faintly aglow in the cold. Beneath every part of this runs one unhurried law: nothing is ever truly used up. Stars do not last. They shine, they spend themselves, and in their dying they give their substance back. A heavy star scatters its forged elements on the blast. A swollen old one sheds its skin in slow, soft shells. All of it rejoins the haze between the stars, where in time it cools, collects, and is built again into suns, into worlds, into the chemistry of living things. Every atom in a body has already gone round this loop, kindled inside a star, flung into the dark, gathered once more into shape. The galaxy is less a stage than a mill of renewal, turning in step with its stars, forever taking apart and starting over. The freight that rides those clouds is stranger and richer than plain wreckage. Sifting the dust that drifts between the stars, researchers keep finding elaborate carbon-bearing molecules. The first rough ingredients. There are ring-shaped, soot-like compounds among them, and simple sugars and alcohols and a good deal more besides. None of it lives, but it is chemically alive with possibility, cooked up in the outer airs of dying stars or inside cold clouds worked over by radiation. Carried light years on the galaxy's winds, these specks settle into the gas that goes on to make stars and planets, and a share of them, long ago, almost surely drifted down onto the infant Earth. The dust is not merely leftover grit. It is a hold full of potential, sailing quietly through the dark. Carry that thought one step on, and the ingredients ride straight into new worlds, where stars are born, planets are born with them, and a young planetary family takes on the chemistry of the cloud it condensed from. Should that cloud hold water and carbon compounds and the rest of biology's starter kit, those things can be sealed into comets, asteroids, and planets in their turn. Certain stretches of the galaxy look especially well stocked with that pre-life chemistry. How widespread life actually is, no one can yet say, but the conditions it needs seem to keep arising of their own accord. Its seeds may be sown across enormous distances, packed into the galaxy's coldest nurseries, biding their time for a place to take. For all its calm tonight, the galaxy we live in is not a thing made once and left alone. It is built, in large part, out of the ruins of others. Across the long eons it has reached out, caught smaller galaxies, pulled them to pieces, and strewn their stars in long, faint ribbons that loop around the disk. This is not ancient history finished long ago. One small companion, a dwarf out toward the constellation of the Archer, is being torn apart in just this way right now, its stars combed slowly into trails. Our spiral feels like a settled home, but it is really a patchwork, quietly pieced from the wreck of many smaller worlds. Counting up those meals is hard, but the galaxy has clearly swallowed a great many. Faint dwarf companions drifted too near across the ages, were seized by its pull, and slowly came undone. Their stars now ride in our halo, our disk, and our trailing streams. By reading the motions and the makeup of stars, astronomers have flagged several of these old swallowings, and one especially large early collision seems to have poured in a flood of stars and reshaped the young galaxy's whole frame. The Milky Way is no spotless original. It is a composite, assembled out of quiet collisions, stitched from the leavings of many vanished neighbors. You can read those leavings written across the sky. Thin threads of stars curve and arc overhead, almost too faint to see until careful maps pull them out. Each thread is the smeared-out corpse of a smaller galaxy that wandered too close and was pulled apart. Its stars dragged into long, delicate trails by the larger galaxy's tides as they orbit. Some wrap right around the wheel like pale ribbons. Others plunge inward toward the center. They are the visible record of old unions, soft collisions that grew our galaxy across uncounted ages. Like a felled tree showing its rings, the galaxy keeps the marks of its past in every strand of stolen light. Some of those captured stars even give themselves away by going against the flow. Most stars circle the center the same general way, but a stubborn few, many of them far out in the halo, run backward, against the galaxy's main turn. These almost certainly came from elsewhere. Born in dwarfs that were later eaten, their reversed paths a quiet badge of foreign birth. It is as though the galaxy keeps old memories, not in pictures but in motion. Tales of ancient swallowings preserved in the patient, contrary turning of stars that refuse to follow the crowd. Their very makeup can be read like a record too. Every star is stamped at birth with a particular blend of elements. A kind it ain't. Some are heavy with iron and calcium and the like, marking a birth in dense, well-seasoned gas. Others are almost pure hydrogen and helium, lit back when the cosmos was still in its infancy. Those differences let scientists sort stars into families, surface old mergers, and piece back together how the Milky Way came to be. In this way, chemistry turns into a kind of clock you can read backward, recovering a star's history like a line of old verse set down in light. By that same reading, plenty of the galaxy's stars are revealed as outsiders. Not everything shining here was born here. Some stars likely first lit in other galaxies, then were captured during a merger, or pitched into our halo from elsewhere in the local crowd. These wanderers from away often travel on odd, far-flung paths, well off the disk, threading the outskirts. Their composition or their motion gives them away, stars that simply do not match the locals. Like newcomers from distant shores, they carry the flavor of other places, other histories, other skies. The galaxy is not a sealed country. It is a slowly gathered mosaic, sewn together by time and in movement. Many of those incomers ride on paths nothing like the tidy circles of home. Rather than gentle rings, they follow long stretched ellipses, looping high above and far below the disk, leaning at strange angles to the main plane. Such stars are mostly relics, survivors of swallowed dwarfs, or of violent gravitational upheavals deep in the past. Those orbits are themselves clues, three-dimensional sketches of the galaxy's turbulent history. By tracing where they go, astronomers reconstruct the hidden architecture of all that mass and memory. They drift like messengers from broken systems, tilted, stretched, and yet still held to the whole. Some of the residents, it turns out, are older than the galaxy that holds them. Not every star here was born in place. Certain halo stars, ancient, starved of metals, wandering on long, tilted paths, seem to have lit even before our galaxy had finished drawing itself together. The best guess is that they began in small primordial galaxies that later folded into our own, ages ago. Their chemistry shows almost nothing heavier than the lightest elements, which points to a birth not long after the very beginning of everything. They move slowly, high above the plane, like elders from a time before there were spirals at all, before there was order. In their faint light, we catch sight of a cosmos that was younger, wilder, still feeling its way into being whatever it would become. A few of those elders push the count almost to the limit. Drifting through the halo, astronomers have turned up a star that may be almost as ancient as the cosmos itself, carrying almost no heavy elements, the mark of a birth, soon after the beginning, before generation upon generation of exploding stars had salted everything around. It probably kindled more than 13 billion years back, far ahead of the galaxy's full forming. It glows quietly now, soft and red, modest in size but immense in history. It is less a star than a sealed message, a living relic from the first faint dawn of all things. This is the lasting value of the dim and metal-starved. In this science, metals means anything heavier than helium, and the very first stars had almost none, because they formed before any earlier suns could forge such things and strew them about. So astronomers hunt down the metal-poorest stars in the halo, faint and old, because each one keeps the chemistry of a vanished age. Read their light, and you look back into the primordial age. The stretch just past the beginning, before galaxies had matured. before our own had pulled itself fully into form. They are fossils, but fossils made of light. The rarest of them are scarcely touched by enrichment at all. Among the most precious objects in the whole galaxy are stars whose outer layers hold almost nothing above helium, some with less than a 10,000th of the iron the Sun carries. They seem to be among the very first to light after the earliest explosions, bearing only the faintest trace of seasoning from a cosmos still inventing itself. They are staggeringly old, staggeringly pure, and scattered through the halo like far lamps lit at the very beginning, each one a glowing, gravity-held signature out of an all-but-forgotten epoch. The dead, too, can outlast the structure around them. Among the faint stars of the halo, astronomers have turned up white dwarfs, the cooling embers of once bright suns that outdate the thin disk of the Milky Way altogether. These quiet remnants took shape back in the galaxy's youth, before its main form had truly set. Their presence points to an earlier round of star-making, a deeper history written into the outskirts. They have smoldered for billions of years, dimming slowly, holding the hushed leftovers of an age when the galaxy was still gathering its form. The disk may be the bright part, yet it is the halo that remembers furthest back. And the galaxy is, even now, not finished growing. Ancient as it is, it keeps drawing in more gas out of the spaces between galaxies, stars off-captured dwarfs, strands of dark matter to deepen its halo. It thickens not the way a creature does, but the way a gravitational thing does, settling and deepening over time. Some of that growth comes softly, through quiet, infalling clouds. Some arrives with violence. As does a Sal Elliot, the galaxy overhead tonight is not the one the dinosaurs knew, and the one our distant descendants may look up at could be larger still, pieced together from the wreck of 1,000 smaller worlds. Its shape, too, keeps shifting. Arms drift, bars build and fade, gas slides in and out. The warped disk slowly alters. Its beauty was never in standing still. It is in the long, changing. That long, quiet changing has a dramatic chapter still ahead of it. High in a clear sky, the great spiral of Andromeda shows only as a soft smudge to the unaided eye, a sister wheel much like our own, lying more than 2 million light-years off. And it is coming. Slowly, steadily, it is falling toward us. And in something like 4.5 billion years, the two giants will meet. The meeting will not be the smash people picture. Stars sit far too thinly for them to strike one another. Instead, the mutual gravity will draw both spirals into long, stretching arcs, tails of stars uncurling into the dark. The central black holes may slowly wind, and after ages of this, the pair will settle into one larger system. A slow, graceful folding together. The future of our home spelled out across the sky. Neither galaxy faces that future alone, though. The Milky Way belongs to a loose company of more than 50 galaxies, a small gathering drifting together through space, with our own spiral and Andromeda as its two heavyweights, each trailing a little family of satellites. Around them scatter lesser dwarfs, faint smudges, and galaxies made almost wholly of dark matter. The whole assembly reaches across upward of 10 million light-years, bound together not by closeness, but by sheer weight. We belong to that family, hushed, far-flung, yet roped to the rest by unseen lines of common drift and answering attraction. For all the gulfs between them, those galaxies are not simply flying apart. A good many are easing slowly toward one another, gravity curving their paths over millions of years into a kind of unhurried choreography. Some of the smallest circle the Milky Way like moons, swinging in, falling, dissolving into trails. Others keep their own counsel but stay tethered, caught in the same web of shared movement. Given enough time, the group may draw in tighter, galaxies merging, fading, or being taken in. It is no fixed arrangement, but a gentle gathering in of scattered island worlds, a family pulled steadily closer by time, by inertia, and by the long reach of gravity. The larger and smaller Magellanic Clouds, a pair of glowing satellite galaxies seen from the southern half of the world, were long taken to be old, settled companions of the Milky Way. Newer evidence hints otherwise, that they may be recent arrivals, only now swinging in for the first time. Their speed and heading suggest this could be their opening pass, not a long partnership, but a distant wandering just now caught by our pull. Their coming has rumpled the outer disk and tugged the galaxy's shape out of true, as though the Milky Way were flinching at the touch of an unexpected guest. The quiet of the night is full of first meetings. The ebb of Neknarabaz. Trailing behind those two clouds runs an immense band of hydrogen, a ribbon drawn out for upward of 100,000 light-years and more. Arcing across the southern heavens, tides peeled it away as the little galaxies swung close to each other and to us. Its surface is only in radiolite, a long trailing. In time, that gas may kindle new suns here, or sink into the halo like a remembered thread strung from one galaxy to the next. Not everything out there obeys the flat plane at all. A few banks of gas and a sprinkling of stars travel on steeply leaning paths, sweeping high over the galaxy's body and far beneath it. These near-polar orbits most likely trace back to old swallowings, when dwarfs or stray clouds were taken in at odd angles and went on circling on their slanted courses ever after, like comets looping a planet. Such crooked orbits are records of disruption, plain reminders that the galaxy is no sealed system but an evolving thing, shaped by the unpredictable drift of cosmic history. And the same vast gravity that gathers these visitors also slowly takes them apart. Just as the moon raises tides on Earth, the enormous mass of the Milky Way pulls tides on everything within reach. Star clusters, satellite galaxies, even tightly bound globular groups all feel its uneven grip. Over time, those tides stretch and warp them, pulling out long trails of stars or prying suns free of their paths. A great many of the dim arcs charted across the sky are exactly this. Clusters caught in the act of coming undone, galaxies being slowly pulled apart. The galaxy does not shatter these things all at once. It unravels them patiently, thread by thread, across millions of years. For all that drift and disruption, our own corner has been gentle with us. and not only cowl. The galaxy may keep a wide belt where life has its best chance, a zone of moderate fortune lying between two hostile extremes. Too near the core, radiation pours and gravity churns. Too far toward the thin, metal-starved rim, and the makings of planets grow scarce. Somewhere in the broad middle, star density is reasonable. The heavier elements like carbon and oxygen and iron are plentiful, and conditions hold steady long enough for slow things to happen. Earth sits within that band, one unremarkable circuit somewhere in the great swirl where, perhaps, life is not the only thing to have found a foothold. Not every world, though, is lucky enough to have a sun at all. Planets are not always bound to a star. Some take shape the usual way and are later cast out of their systems. Others may have come into being with no star at all. These are the wanderers, worlds loose in the galaxy, cold, lightless, and solitary. They are hard to find, but the surveys hint that their number could run into the billions, a few even far out in the halo where stars grow sparse. With no sun to warm them, they coast on nothing but the faint heat left in their own cores. They are the orphans of the wheel, drifting on long, lonely roads through the blackness between the stars. There is a quiet strangeness, too, in how the galaxy hangs in our sky. From the ground, the band of the Milky Way arcs overhead in a graceful sweep, but it does not lie flush with the plane of our own solstice. The great flat disk that holds the bulk of the galaxy's suns is canted at a steep angle to the path the sun and planets trace. That tilt is why the band rises slantwise and shifts with the turning of the year. We are fully part of the galaxy, and yet our little system sits cocked a little sideways within it. A small, tilted raft floating across a far larger, slowly spinning sea. Measuring all of this from the inside takes some clever tricks, and one of the oldest leans on stars that will not hold still. Certain stars throb in brightness on a steady beat, swelling and shrinking like slow, luminous hearts. And for some kinds, the rhythm of that pulse is tied directly to how much light they truly pour out. Time, how long one takes to brighten and fade, and you know its real output. Set that against how bright it merely looks, and its distance falls out of the arithmetic. Such stars become measuring rods laid across the dark, helping chart the size and shape and scale of the galaxy. Small lights that take the measure of the night, blinking out their slow code through the spiral. In our own age, one mission above all has redrawn the map. A spacecraft set high above the Earth has been logging where well over 1 billion stars sit, how they move, and how brightly they shine, building the most exact three-dimensional picture of the Milky Way ever assembled. It has traced streams left by shredded dwarfs, gauged the bend in the disk, and followed the sun's own slow road with astonishing precision. Each fresh release of its data sharpens the view a little more, turning what used to be a vague blur of stars into a crisp, living chart. It is the most ambitious star map ever attempted, a quiet revolution playing out among the stars. All of that mapping keeps circling back to the same bright band overhead. Look up on a truly dark night, away from any glare, and a hazy river of light crosses the sky. That is the thickest slice of the disk seen edge on. Less a line than a depth. A broad, flattened lane holding most of the galaxy's suns at once. Through it, the stars press close. The dust lies in heavy sheets, and fresh suns are forever catching light. From where we sit, we are looking lengthwise down the grain of the galaxy, straight along its richest corridors. That band is not only lovely, it is the crowded, humming quarter where the bulk of stars are born and where the bulk of them die. And the band is brightest in one direction above all. The true center of the wheel lies off toward the constellation of the Archer, a dense, glowing pile-up of suns and dust and weight we cannot unique. From the ground, the very middle stays hidden in ordinary light. The dust hangs too thick before it. But the region blazes in infrared and radio, and even to the naked eye it looks fuller, more luminous, heaped with the blended light of countless overlapping suns. We keep to a quiet outer district of the disk, far from that hub. Yet when we turn our gaze inward, we are looking toward the teeming city at the galaxy's heart, the bright, dense heart of everything turning around us. And in the end, for all our maps and instruments, we glimpse only the smallest part of what is truly there. Light is swallowed by dust. Motion hides in silence. The unseen mass outweighs everything that shines. Between every star lies a gulf, and inside every gulf, possibility. The Milky Way is not only what shows itself, it is also what we guess at, what we deduce, what we are still straining to grasp. It holds light from long ago, and suns not yet born, drifting lightless worlds and questions with no answers yet. And somewhere inside all of that vastness, improbably, we find ourselves one small planet, circling one quiet star, adrift in a story far too wide for any single pair of eyes. So let the stars begin to soften now behind your thoughts. We have wandered through a great many quiet truths tonight. The bend in the disk and the far halo stars, newborn suns and long-dead embers, dust and gas and light and shadow and all that lies between. We have followed the slow swaying of the sun, drifted along the spiral lanes, and turned our gaze toward the glowing heart hidden behind its curtains of dust. And here is the gentlest truth of all. You are not merely watching this galaxy. You belong to it. The iron carried in your blood was hammered together inside dying stars. The very oxygen filling your lungs right now was shaped in ancient fires and strewn on ancient winds. Every atom in you traces its line back to the same matter that lights the suns and drifts through the cold clouds between doing them. So there is nothing left to do but rest. As you lie here, the galaxy goes on turning, unhurried, exactly as it has for billions of years. Far away, new stars are kindling in the dark. Light that left its source long before you were born is still crossing the emptiness toward you. Silent orbits keep their slow appointments, and you are held inside all of it. Let your breathing lengthen and slow. Let your thoughts grow soft and dim, like the last light fading from the sky. There is nowhere to be, and nothing to reach for. Only the long, gentle turning, carrying you down toward sleep. Rest now, and dream softly.